Hello Java developers! We are here today for one more tip, and the tip for today is how to use MicroProfile Opentracing with an Opentracing implementation as Jager. Well, first we need to understand what is tracing an application. So I have here three microservices. A microservice A implemented using Halidon microprofile that calls a microservice B implemented using Spring Boot that saves the information to a database and to a Kafka topic, and also microservice C written in Node.js. Note here that after making this request, I can go to the Jager UI and see all the services involved. So I'll get here every request that was made through the microservice A, and I can see that my requests have been traced going through microservice A, B, and C. We can see how long it took and also all the details involved in this request. We can see here that the Heldon Weber server received the first request with this slash serial slash Raphael URL, and we can see the details of the logs, and also the JAX-RS server component has been invoked in this URL. And finally, there was a class called call microservice B serial in the class myService invoked. And then, before calling the microservice B, my JAX-RS client has been invoked, passing here the URL of the microservice B. So how does that work? We can see here that every JAX-RS server requests on the server are traced automatically. Plus, every invocation that I do for other microservices using JAX-RS client or MicroProfile REST client are also traced automatically. So I just need to include the Opentracing dependencies in my implementation, and those requests are traced automatically. However, for some method calls, we should use the traced annotation. So internal requests, as I'm doing here for this method, they need to be annotated with the traced annotation. Otherwise, we will not see this operation registered in the Jager UI. Another thing that we need to be aware is that in this case where I used Halidon, I can choose between two types of tracing. I can use Jager or Zipkin as a tracing. And the reason that I used Jager over Zipkin is written in this blog post here, where it says, despite Zipkin being around for a while longer and being more mature, Jager has seen some good adoption thanks to several factors, such as good language coverage of Opentrace compatible clients, low memory footprint, and a modern scalable design. So to configure Jager tracing together with Halidon, I have a series of configurations that I can do that I passed here as environment variables. I've ran all microservices using Docker Compose here. So I have Jager running that exposes the port 6831 as UDP to receive all the spams. And for microservice A, I have here the name of the service, I have the protocol, the host, the port, the URL for the microservice B. That's not part of the tracing, but everything related to tracing you can see here. And why is that important? Because if you decide to run in another environment, just like I will do now with Istio, you can just switch some environment variables. So let's see this microservices running inside a Kubernetes cluster with Istio. So I've performed here a request inside my Kubernetes cluster with Istio. It's the same behavior, microservice A calling microservice B and C. And now I can go to my Jager Console running inside my Kubernetes cluster. We can see here that now I have the Istio ingress gateway appearing as the name of the service, because all requests starts in Istio ingress gateway. We can see that the sidecar proxy is invoked before calling the application itself. Then the request is propagated to the next proxy, the microservice B, to finally call the application, and microservice C is invoked. The proxy of microservice C is invoked before calling the microservice C itself. Let's take a look here on span. So if I get a span here, you can see that the Istio ingress gateway has been invoked, and also before having the microservice A receiving requests, we can see that the proxy of this the sidecar proxy that is running together with the microservice A has been invoked. So every inbound request receives is intercepted by the proxy. So the microservice A is called, and also every outbound request is also intercepted by the sidecar proxy. So we can see here that before calling the microservice B, the proxy has been invoked as well. So this is small. This is a small change in the behavior of the tracing when we are using an application that has Istio capabilities and a sidecar proxy running together with your application. But we need to understand that when we decide to use Jager on Istio, we have at least two considerations. The first one is that the Istio sidecar proxy envoy generates the initial B3 HTTP headers if they are not provided by request. So B3 is a different format to propagate the span from a microservice A to a microservice B. It uses this format here where you can see XB3 trace ID, XB3 parent span ID, XB3 span ID. The default, if you don't specify that you want to use B3 headers, will be the Uber trace ID format, which is called also as a Uber headers, where you have the trace ID, span ID, parent span IDs. So when I decided to deploy my application inside Kubernetes, the changes that I had to make is changing the propagation to use the B3 format. If this is not informed, then the Uber header will be used. Plus, we have the same configurations, and something that I need to change here is the tracing host. So I need to inform that I will send all spams to the Jager agent, which is running inside the Istio system namespace. And finally, the second consideration is that although an Istio sidecar will process both inbound and outbound requests for an associated application instance, it has no implicit way of correlating the outbound request to the inbound request that calls them. The only way to this correlation can be achieved is if the application propagates relevant information, in example headers, from the inbound request to the outbound request. But let's recap. All the MicroProfile Opentracing capabilities will automatically intercept the inbound request on a JAX-RS server and propagate it to the outbound request if you decide to use MicroProfile REST client or JAX-RS REST client. So I hope that you enjoyed the tip for today, and also be aware that the implementation that I used it's in this GitHub repo where you can see my microservice A implemented using MicroProfile with Helidon, my microservice B with Spring Boot, and my microservice C using Node.js. And don't forget that I'm running a series of videos just presenting all MicroProfile APIs. So subscribe to this channel to be aware of more contents like this. And see you in the next video. See ya! Bye bye!